The REXX OSF Host Environment is the primary tool used within your Ops MVS rules to dispatch an asynchronous program to perform any type of wait logic that cannot be performed directly within the Ops MVS rule. These common wait type of actions include manipulating the command response from a ZOS command in which no OPSREX function exists, prompting an operator with a WTOR to determine how to proceed with the automated logic, any type of file I/O, as well as any logic that is utilizing Ops MVS sysplex variables. The programs that get dispatched to the servers will reside within the sysexec DD concatenation of the OPSOSF procedure. If the OSF host environment is used within an OPSREX program already running in a server, that program will be dispatched asynchronously to another OPSOSF server. Before looking at the simple OSF coding syntax, let's first discuss the three possible types or classifications of OPSOSF servers. Regular or OSF servers will make up the primary servers where most of your OPSREX programs will be dispatched by the logic within your Ops MVS rules. These servers are configured and controlled via Ops MVS parms that begin with OSF, such as OSF min and OSF max, which define the minimum and maximum number of OSF servers that are running, as well as OSF run and OSF wait parms, which define the max time limits that the programs running in these servers can execute. Long-running servers, or OSF TSL servers, are controlled by similar parms but begin with OSF TSL. These types of servers are designated to execute longer running programs, as they would have higher time limit parms as defined by their OSF TSL run and OSF TSL wait parm values. Long-running programs may include logic that issue WTORs and prompt for a manual reply, or a series of complex and detailed system commands that are manipulating the response of many different types of commands. The last type of servers are called priority or OSF TSP servers. These servers would be reserved for priority programs that contain logic that should run ASAP. This may include disaster recovery procedures or proactive programs that are automating events on the system that may result in bigger system issues if they are not addressed immediately. Priority servers are controlled via the same type of Ops MVS parms, but begin with OSF TSP. Refer to the CA Ops MVS documentation for complete details on all parameters that regulate the quantity and availability of these types of servers within your Ops MVS configuration. The standard syntax for the REXX OSF host environments is pretty straightforward. The address OSF instruction will be coded to dispatch programs to basic servers, the address OSF TSL instruction to dispatch a program to a long-running server, and the address OSF TSP instruction to direct the program to a priority ops server. Like all host environment commands, the command string sent to the OSF host environment will be contained in quotes. The most common command string used within your Ops MVS rules will include the invocation of the OI or Ops IMAX module, which creates the actual OPSREX environment in the server, along with the actual program name and any arguments that are being passed to the program. If the calling program from the rule will be executing some type of work not supported in OPSREX and it must run in TSOE, you simply omit the OI instruction and call the program to run in TSO with the % program name. In these examples, the address OSF host environment is being instructed to dispatch the TSO check OPSREX program with a specific list of arguments. Again, the OI module is needed to establish the OPSREX environment in the server, allowing the TSO check program to access all OPSREX automation tools. The last example simply demonstrates how you would dispatch a TSOE program to an ops server if needed. In this case, the TSOE program DB2 stats will be dispatched to a long-running ops server. This sample code is illustrating the most basic form of all address OSF commands from within AOF rules. The logic of this message rule is simply firing on the issuance of the IST 521I gbind event from a particular VTAM node, extracting the filling node name, and then dispatching an OPSREXX program called IST 521I to an OPSOSF server. The filling node will be passed as an argument to the program. This program would reside in the sysexec allocations of the OPSOSF procedure and would contain the logic to accept the calling filling node argument and then perform the desired asynchronous logic to complete the automated application. This may be an action to issue a VTAM display command to this node so that the returned output can be manipulated and acted upon. Using the ops log, let's take a look at the audit trail messages generated by any rule that triggers a program to an OPSOSF server. Using this command rule as a trigger that invokes the disaster or OPSREXX program to a priority OPSOSF server, upon the issuing of the disaster sudo command, you can not only trace the rule logic, but also determine what server was processing the triggered program. Note the first line of the ops log. The disaster command event was issued by a specific TSO user, which would have triggered this rule. The address OSF TSP logic in the rule resulted in the OPS 3724T audit trail message being issued. The OPS 3724 server audit message can be used to determine what rule invoked the program along with the server type and the OSF command string. From the ops log with the job name and ASID columns displayed, you can further determine the specific server that executed the triggered program. In this particular case, the OPSOSF server with the ACID of 002A executed the logic of the triggered disaster program. This, of course, is extremely useful during any high-volume server usage time and you're trying to analyze or debug what server was executing a specific program from some triggering AOF rule. Many sample OPS MVS AOF rules exist that demonstrate address OSF host environment coding examples. These samples can be used as a syntax template that of course can be copied as you create your OPS MVS automation, and the logic warrants dispatching a program from a rule to an OPSOSF server. Locate your installation's CCLX rules dataset to access these specific members. Thank you for viewing this video. For more detailed information about the OPS MVS OSF host environment and the complete OPS MVS product, click the information bubble in the top right corner to load the product page. From there you can go to product documentation, visit the CA communities, or see the learning path.